So now for our speaker, who is just going to be very, very exciting today, and it's wonderful to be able to introduce General Dailey. I want to just make a couple of remarks about what this luncheon and this lecture is. The Durand Lectureship in Public Policy was established and named in honor of Dr. William F. Durand. It recognizes notable achievements by a scientific or technical leader whose contributions have led directly to the understanding and application of the science and technology of aeronautics and astronautics for the betterment of mankind. It's a wonderful, wonderful, prestigious award. It is given at this ASM every year, and in fact, the lecture itself is the highlight of the conference. Past recipients that you may have witnessed, to name just a few, include Norm Augustine, Robert Siemens, and Robert Bigelow. So today, joining that list of distinguished lecturers is General John Jack Dailey, a retired United States Marine Corps four-star general and pilot. He assumed his duties of director of the Smithsonian National Air and Space Museum in Washington, D.C. in January 2010. Since assuming his position, General Dailey has led efforts to expand the size and scope of the museum and to vastly increase its public outreach. If you have ever visited the museum in Washington, you know what a treasure it is, and if you haven't visited it, put this on your list with your family. It's just an amazing place. In 2003, expanding from the Downtown Museum in Washington, and in conjunction with the Centennial of Flight, the museum opened a second building, the Stephen F. Udvar-Hazy Center in Chantilly, Virginia, quite close to Dulles Airport. More than 300 aircraft and space artifacts are housed in its two enormous hangars, the Boeing Aviation Hangar and the James S. McDonnell Space Hangar. The Downtown Museum and Udvar-Hazy together welcome about 8 million visitors a year. Just amazing. General Dailey was previously at the National Aeronautics and Space Administration, NASA, where he led the agency's internal operations as the Associate Deputy Administrator. Also, during his NASA tenure, he served on the President's Management Council and was a national delegate supporting NATO. General Dailey's career in the Marine Corps spans 36 years and included extensive command and staff experience. General Dailey has flown more than 7,000 hours in a variety of aircraft and helicopters. During 2 tours in Vietnam, he flew 450 missions. General Dailey was promoted to the rank of general and named Assistant Commandant of the Marine Corps in 1990. He has numerous personal decorations for his service in the Marine Corps and at NASA. General Dailey was born in Quantico, Virginia, and earned his Bachelor of Science degree from the University of California, Los Angeles in 1956. So in 1956, we were about to, in this country, realize a space race. And that occurred to me as I was reading and becoming familiar with General Dailey's bio. In 1957, Sputnik was launched. So General Dailey has been a major player and a contributor to the space program and to the aerospace community since the beginning of that space race and throughout his career. This afternoon, General Dailey will discuss how lessons from the past serve to advance future capabilities to meet the needs of our society that has become increasingly dependent on aerospace technologies. General Dailey, the Institute is honored to recognize you today, and on behalf of AIAA and our sponsor and all of us in this room, I welcome you and look forward to your presentation. Do you want us to stay up here?
Well, thank you, Mary, and good afternoon, ladies and gentlemen. I'll tell you, I was really pumped up when I came here and saw the size of the crowd here today to hear these remarks until I found out that the lunch was free. And also the topic might be a little misleading. When I started thinking about what to try to cover, I think a more appropriate title would be "There's no way in hell you could do it the way we used to." Because of the changes in regulations, the changes in the opportunities to collaborate both officially and socially have been constrained to a point where I think that we've lost quite a bit from what used to be possible in the days of getting where we could get together and we could talk about things. We didn't have to worry about having the appropriate crowd and the number of people at the same event and that sort of thing. But you know, if you look at Professor Durand, I think this lecture is perfectly named because he was an incredible individual, born in 1859 in Beacon Falls, Connecticut. He was on a farm. His father was a farmer, and he, as a youth, was constantly modifying their equipment to make it more efficient or work better. But in the process, he decided that he wanted to go to the Naval Academy. And while he was in high school, he took a sabbatical. That's pretty much what it was, because he took a year off and worked in a machine shop because he felt that knowledge would be more useful to him at the Naval Academy than the curriculum he was getting in his high school. And it turned out that it was true. He got in, he graduated number 2 in his class, in the class of 1880. And immediately went to sea in a sailing ship that had a steam engine as an auxiliary power source. So he did 3 years at sea on this sailing vessel and decided that the Navy was not the life for him, which doesn't surprise me a bit. But he had a tremendous interest in all the things mechanical associated with sailing and with ships. But the Navy had a program that enabled naval officers with mechanical backgrounds to do exchange tours, essentially, with universities. And he was sent to Lafayette University, where they had a program that interested him a great deal, and he was able to begin his research on a variable pitch screw for a ship, and was later able to carry that out at Cornell. But he was a very energetic person, and every place he went, he ended up being in charge of whatever it was that he was assigned, because everybody else just kind of got out of the way and let him get going. But he was at Lafayette for about 6 years, and then was hired away by Michigan State College in those days, and which became Michigan State University, to develop the Department of Mechanical Engineering, which he did. And he also established a Department of Electrical Engineering at the same time. But he stayed there for about 13 years and then saw a position at Purdue that interested him. He applied for the position and was accepted. And then a position at Cornell came available immediately. And so he had a little bit of a dilemma because he really wanted to go to Cornell. So he went to the president of Cornell and talked to him. He says, if you can disengage yourself from Purdue without ill feelings, then we'll take you up here. And that's what happened. So when he got to Cornell, then he actually established their Department of Mechanical Engineering. But he did much more than that, because he was constantly being used as an advisor and consultant and being on other boards and this sort of thing. But he loved teaching. It was really, he found the place where he really wanted to be. But the more important part of it was that he found that he could do coordinated or extended research, so he could lay out a plan and then carry it through rather than just working on a particular element of somebody else's program. And this continued for quite some time, and then the president of Cornell passed away, and they hired his replacement from Stanford. And right after he arrived, Stanford came to Dr. Durand and said, how about coming out here and taking over and establishing a mechanical engineering department at Stanford, which he did. And he went there, that was in 1924, so this is still quite a while ago. But prior to that, he had been appointed to NACA and was one of the 4 civilian appointees to the first board there. And he took his work that he had perfected at Cornell with the variable pitch propeller and applied that to aviation. And he continued through several other iterations with other important developments that NACA was working on at that time. And I think that, again, he was being used as a consultant. But so it was kind of, he was torn between his university job and getting involved fully with the government's development of some of these things. Well, then, as World War II approached, and by the way, he had to retire from Stanford in 1924 because of age. 17 years later, World War II starts, and he's right in the middle of everything again. He moved from Palo Alto to Washington, D.C. to become part of the NACA activities and other requirements that they had for him in government. And one of the things that they did was they pooled all of the aviation patents, made them available to everybody, so that everyone trying to develop capabilities for the country was able to benefit from everything that was available. And during that time, he was invited to become a member of the Guggenheim Board for Aeronautics. And one of the things that they asked him to do after he'd been with them for a short period was to prepare an encyclopedia of aeronautical data. And he told them that that was not probably worthwhile because it was changing so rapidly that it would be obsolete or out of date by the time anything was published. But there was a core of information, of engineering information and knowledge that would not change. And it could be developed into something that could really be useful as a foundation for the aeronautic industry. And they decided that's what's going to happen. He then collaborated with Dr. von Karman, and they decided to divide it into 20 monographs, and actually Durand wrote 3 of them, but they had the best experts in the world that they could find write the others. And but the publisher in the United States, who was not sure of what the sales potential was going to be of this series, so he backed out, and they had no one to publish it. A German publisher in Berlin, this 1935, volunteered to do it, and they published these 20 volumes, and they were distributed. And World War II then started for us. Everyone wanted one of these, and they couldn't get them reproduced because the publisher was no longer available. So Caltech had to use the offset printing technique to reproduce all of these for the entire country, but it provided a foundation of knowledge that had been gathered around the world of the most important elements of what they were trying to do. And it really was probably one of the most critical things that he provided in terms of beneficial outcomes for the country, particularly when it came to the aeronautics area. He had, when he went to the Naval Academy, he took French. It was required, and he didn't pay much attention to it because he wasn't interested. And so he got a barely passing grade. He was so embarrassed by this that he took on the task to train himself in French so that when he came back he could, and actually graduated at the number 2 in his class. But in the meantime, he got interested in Spanish, Italian, and German, which he taught himself also. So it gives you kind of a feel for this guy and what he could do and how he could do it. But at the World Power Conference in 1935, he gave his opening address in English, French, German, and Spanish, which were the approved languages for the conference. So he was more than an engineer. He was essentially he could do anything that he wanted, it looked like. But one of the things that he, in his hydro work with the Navy and also in aircraft with the hydraulics and this other sort of thing, he became an expert in water management and was one of the people responsible for the Hoover Dam being constructed and also for the piping of the water from the Colorado to California and all of the water activities out in California, essentially. So he was actually unlimited in what he could do in terms of whatever they assigned him. He just took it on and did it. The thing that I think when he reflected on his life, he said that he credited the Naval Academy with giving him the direction, because when he came, it introduced him to competition. And it also gave him a goal, because he'd never had any ambition or never had a goal of things that he wanted to accomplish. And he found the love of study, to be able to improve himself and to learn all these things and then also to apply them. But I think that when we talk about some of these things that may be important to the total community, and I realize, there's competition sensitivities to almost everything now, but there are things that can be done. And when my experience at NASA was, it opened my eyes to a few things in terms of what we were trying to do and how we were trying to do it. We had to write a strategic plan, and we tried to get guidance. What's the direction that this agency should go? And essentially got no guidance at all, other than the fact that you figure it out and we'll approve it. And so that's what we did. We wrote a plan, and we came through with various disciplines that should be pursued and the way they should be, and that way they would be pursued within that particular area. And the one that I want to use as an example was aeronautics, because we had, NASA does fundamental research. And one of the reasons they don't get credit for very many products is because once it gets to the product level, somebody takes it over and develops it into a product and then puts their name on it. But we were trying to figure out, we have money in this aeronautics budget, what should we be spending it on? So we went to each one of the contractors that we had business with and said, give us your fundamental technology requirements 15 years from now. And essentially the answer we got was, we are so focused on the next quarter's profits that we haven't got time to think about this, and so it's impractical for us to, and besides, we're not sure we want to tell you what we're thinking about out there. So we went to associations, including AIAA, and said, if you could poll your membership and see if you could get a feel for what it is that we could be providing in this fundamental research area that would then benefit them or the whole community at some time in the future, and maybe it would be a core element the way Dr. Durand developed his. But and we also were unsuccessful, the associations were unsuccessful in getting information along that line. So we came up with a plan and developed 4 fundamental areas that we wanted to take a look at, and they were all associated with a high-speed civil transport. And it was, with the engine, it was emissions and noise. With the airframes, it was composite materials, and the sonic boom, of course, was the other issue. And part of the testing that we did, for example, NASA Langley developed the composite wing box for civil transport, and did testing and strength and some of the characteristics of the composites that were very useful when people actually started manufacturing them. We had $800 million in that program, and we testified before Congress what we were doing and what we were trying to do for the country with the program. When the contractors came in to testify for various programs and were asked the question, what are you going to do with the high-speed civil transport? And the answer was, we're not going to do anything with it. $800 million was taken out of the NASA budget because the research we were doing was not aimed at doing something that the commercial portion of the country needed. And it was, so it gets back to this, why did we do it? What were we basing it on? And well, of course, we based it on what we saw as the requirements of the future and what people were going to need to have available to them when they started to develop aircraft of this type. By the way, that supersonic commercial transport that NASA was working on was 303 feet long. That's 100 feet longer than the Concorde. And it was going to go Mach 2.4. So it'd carry about 300 passengers, which was the economic break point to where you could get enough people on there to pay for the gas. So it really brought it home to me, and it's something that I've thought about. This is, by the way, this is back in the 90s that this happened. But it was, NASA doesn't have that kind of money anymore, but it was a real kind of a wake-up call for me that we really is important that we know what we're trying to do and how we're going to try to do it as a country. And we see it at the Smithsonian. We have a lot of exposure to a lot of different aspects of American life, particularly. But when we look at what we're trying to do and what the education of this country and its children are taking place, we are completely committed to STEM education: the science, technology, engineering, and math. And it's important. I want to bring this up here because I want to thank you. The Smithsonian is funded at about the 60% level with federal funds. By the time it gets down to my level, it's about 50% because the castle skims off the top and for their needs. But all that does is pay for the civil servants that work at the museum. It doesn't pay for any programs or any gallery updates or any acquisitions or anything that we do. All of that is totally dependent upon donations from individuals and corporations. So we have a robust education program that starts, by the way, with 5-year-olds. It's a Center for Early Learning, and it has been funded, or is being funded by you and your corporations with these. We have Super Science Saturdays, we have Family Days, we have fly-ins, we have demonstrations of, we have lecture series, we have just about, and now we have our own observatory, by the way. It's right there on the mall, which is not the most ideal observation point, unless you want to look in somebody's window, but but what we do is we show people how you do it. Here's the way you use a telescope, and it's turned out that we can't staff it to the level that of the interest that's coming in there. So there's lots of things that are going on, but I think the important thing for us to think about, if we want to keep our country out front and be able to compete, because the competition is so much greater now and so much more capable than it's ever been in our past. We need to think about the future in these kids, particularly getting them prepared. But the thing that we're seeing, it's not getting them prepared so much as is interesting them in coming into the aerospace business. When I talk to children, I'll say, how would you like to be? You want to be in aerospace? They said, why would I want to be in that? All the airlines are going out of business. Nobody's building any airplanes anymore. They're all drones, It's a kind of a what's left to do. And so one of our motto at the Air and Space Museum is commemorate, educate, and inspire. We commemorate by getting these spectacular systems that have been developed over the years. We study them and we become experts in them, and we then educate the public on those capabilities. But it's the inspiration that we're looking for. We're trying to grab these kids and send them home wanting to know more and to bring their parents back. The Center for Early Learning, we are teaching them physics at 5 years old, and they don't know that they're learning it. But what we're hoping is when they get into school and they start getting this as a formal curriculum, they won't be intimidated. They'll say, I know how to do this. I've done this before. And we've partnered with Sesame Street, and it's they know how to get kids. You'll see a 5-year-old sitting there for 40 minutes listening to these puppets or whatever they might be that we're using to talk to them about. We have a Dr. Einstein puppet. He talks about, they sing Twinkle, Twinkle, Little Star, and then they find out which star they were talking about. So it's really starting at the grassroots, but we haven't had it going long enough to know whether it's going to work or how well it's going to work, but we know we have kids bringing their parents back, and we don't send them home until they know the 4 forces of flight, and their parents are surprised, by the way, that they do. So it's with my granddaughters, I tell them, anytime I ask you a question, if you don't get the answer right, you owe me $1. If you get it right, I'll give you $1. They don't like this plan, by the way, but I keep it pretty simple, and they're winning because they can but they can stop right in the middle of something and tell me the answers because they're paying attention to this. So it's up to all of us. And Dr. Durand kind of sets an example of, he died at 99 years and 5 months old. And so and up until that time, he was completely active until the last 3 or 4 years of his life. So and he was constantly trying to find newer ways and better ways to do it. But when he's characterized by his friends, he was the nicest person they had ever met. He would help anyone do anything. It seemed never to be self-centered in what's in it for me, but what's in it for the country or the organization that he was working for. He was totally committed to that. So I think the fact that that you've named this award after him, even though he really was not a civil servant, probably in the pure sense of the word, because he was really a college professor who did government work as a consultant but was always in high demand. The fact that he actually moved away from his home in Palo Alto during World War II and lived in Washington, D.C., so he could commit full time to the NACA and the other activities that he had going is a credit to him and to anyone who would take that approach. So in closing, that's the only message I have. There are ways to do it in the past. There are things that we may want to think about, and collaboration is one of them. And there are boundaries to that, and I know you can't cross them. By the way, my only experience with the corporate world was as a consultant very briefly on some security matters. And somebody said, hey, you've got a really good plan here. Could we use it? I said, sure. I found out that you don't do that stuff in industry. If you've got a good plan, keep it and don't let the other guy have it. Well, but maybe that's not the way to do it. Maybe if we should all try to get everybody as good as they can be. And I realize that it comes down to competition and getting the contracts and making money and all those things. But the more flow and the more interaction, particularly between government and industry, that's something that I think President Eisenhower did us a disservice when he characterized it as the military-industrial complex, because that group got things done, and they did it really well. So I think that some lessening of some of the restrictions would help us greatly to, and we better be paying attention because the rest of the world is running as fast as they can too. So thank you very much for this opportunity this afternoon. Even though the lunch was free, I still feel good that you're all still here. Thank you very much.
Thank you, Jack. I think it's very fitting the Durand Lecture and Award has not been given since 2004, and I wanted very much to revitalize the lectureship, and how fitting that we revitalize it with a historic perspective about the gentleman whose name is on the award. So thank you very much, Jack. That was wonderful. And it is my honor and privilege on behalf of AIAA to present you with the Durand Award for Public Service. And the certificate.
Perfect.
And we've got it from photographer. Yep, that's always looking for where he was.
I don't see a flash.
I don't know where he is. Oh, there. Okay, good.
Okay.
Great. Thank you.
Well,
thank you, sir. Thank you very much.
Appreciate it. Yeah. Thank you very much. I'm really into medals.
Thanks, Jack. And I want to thank our sponsors, again, Lockheed Martin, for their support for this luncheon. And certainly for all of you for taking time out of the busy conference to come. Our next public policy event is Congressional Visits Day, and that will be March 19 and 20. And the website is open. Registration is up. We encourage you, there are brochures on your chair. Please consider joining us. We'll have 10 issues this year that will be presented to the board on Friday. The website will have those issues as soon as they are approved, and we'll start the webinar orientations on the 7th of February. So please mark your calendars and join us. Again, thank you for joining us for this luncheon, and have a great conference. Thank you.